Hello, I am Benjamin Oates. My project is PAFinder, a personal assistant as a service that helps Singaporean shoppers or any shoppers find the cheapest price for any item just by sending a photo to a Telegram bot. The motivation comes from a real problem. Modern cloud systems decompose into independent scalable services, and that's exactly the architecture I wanted to apply here. As a shopper in Singapore, it is difficult to know if you're getting the best deal while shopping in store. You would have to manually check Shopee, Lazada, and Amazon separately, and that is assuming you even know the brand and model of what you're looking for. With major sale events such as 11/11 and Chinese New Year sale, prices vary wildly across platforms and change constantly. The core problem is this. How can a shopper instantly find the cheapest price for any item they see across multiple platforms without knowing the brand or model? Existing tools such as Shopee's visual search only shows Shopee results. Google Lens does not compare prices, and none of them proactively alert you when a price drops after you have walked away. Looking at existing visual search systems, Google Lens uses the Cloud Vision API and Google Shopping API. It identifies products well, but does not have price comparison and no memory of your preferences, meaning that it will just give you any items that look similar but not within your budget. Shopee's visual search uses an in-house CNN and performs well, but is limited entirely to Shopee's catalog, meaning items from Lazada may be cheaper, but it will not be displayed. PAFinder takes a different approach. Cloud Vision API extracts structured features from the image and then sends it out to multiple e-commerce APIs in parallel, giving cross-platform results. On the conversational side, Amazon Alexa supports shopping through the Alexa Skills Kit and Amazon's product advertising API, but it is voice only and Amazon exclusive. Maya, built by Mientra and uses the OpenAI ChatGPT API for context-aware shopping conversations, but it is also restricted to a single platform. For personal assistant frameworks, OpenClaw has 3.2 million monthly active users and a 92% retention rate. This shows real demand for this type of services. However, OpenClaw is not shopping specific. The gap across all of these are the same. There is no single tool that does image search, cross-platform comparison, and proactively monitors price changes. PAFinder solves this with 5 Flask microservices, each independently deployable and exposing its own RESTful endpoints. The image recognition service on port 5001 calls Cloud Vision API. Product search on port 5002 queries Shopee, Lazada, and Amazon in parallel. Price comparison normalizes everything to SGD, so the comparison can be made easier. The cart service handles the shopping cart and watched items. And the shopping agent on port 5000 acts as the API gateway, controlling all the others. Clients, such as the Telegram bot or the web dashboard, only ever talks to the agent. And they never ever call downstream services directly. The conversational layer is what makes this whole system feel like a personal assistant rather than a simple search tool. Every text message that the user sends is forwarded to Claude API alongside the full conversation history, the last search results, and the current cut. Claude reads all of that context and returns a structured JSON object. The action dispatcher then calls the appropriate microservice REST endpoint. This means users can type things like find something that is cheaper, add the first one, or only show certain results. There is no commands for the users to remember, as they can just type anything as long as it can be understood. When a photo comes in, the shopping agent applies one of 4 search strategies based on the confidence of its vision analysis. If a brand logo is detected with over 80% confidence, it uses brand targeted search, meaning that it only searches for that specific brand. If a category's confidence is over 70%, it uses category specific search, meaning it will only search for products in that category. If only style attributes are found, it will use style-based, meaning it will search for items in a similar style, such as a green shirt, uh, a puffer jacket. If confidence is low everywhere, it will simply use full search to find all available features. This strategy allows PAFinder to return useful results, whether you're using a photo of a branded item or a plain unbranded item. For deployment, every microservice runs in its own Docker container. The entire system, all services, and database volume starts with a single command. Each service exposes a gate endpoint so Docker can detect and auto restart any failed container. This means that the system can run continuously without any manual intervention. Nginx sits in front of the shopping agent as a reverse proxy. If load increases, running docker compose scale agent API 3 spawns 3 agent instances, and Nginx immediately distributes traffic across them. This allows for elastic scaling. To summarize what PAFinder achieves, PAFinder, PAFinder achieves independent microservices over RESTful APIs, a Claude NLU layer for plain English interaction, so that it doesn't feel like you're messaging a bot, but instead a real personal assistant. Cross-platform price comparisons across different e-commerce platforms, 24/7 Docker deployment so that the system can always be used whenever, and proactive price drop alerts. The main limitation is that there is around 7 seconds of latency for photo searches due to external API round trips. Shopee and Lazada are accessed through Rapid API, which are subject to rate limits, meaning that the prices fetched could be delayed and not fully accurate. Thank you.